Hi everyone, welcome to another episode. Today's question seems pretty straightforward. Like the description is very small, so you need to find the maximus square, which is if you are given a 2D binary matrix filled with zeros and ones, find the largest square containing only zeros or only ones, my bad, and return its area. Uh, let's look at this problem. So let me draw 0, 0, 1, 0, 1, 0. Cool. So basically what they are saying is a square is basically something that has equal sides, right? So in our case, this will be a square, and then this will be a square of maximum area, which is 2. Obviously all these individual ones are also squares, but they are of area 1, right? Now how do we find this out? This Now it's a 2D metric, so I'm assuming uh, brute force would be you iterate over each element, and when you are at that particular element, you traverse diagonally, horizontally and vertically on all the directions till you don't get 0. So let's say if I start from this point, so I for to go vertically, and I stop at 3 jumps or 2 jumps, but including this whole distance is 3, right? So it's 3 on the horizontal, uh, 1 and 2 I stop here. So it's 2 on the vertical, and then diagonally also it's 2. So obviously square, it's a square, it has to be a square, so it has to be of equal size, right? All the sides have to be equal. So I have to take minimum of my traversal, which is horizontal, vertical and diagonal, which is 2 here. So the max area that I get is 4, which is side is 2, so 2 into 2 is 4, because area of square is square of the side of the square, right? Now that is the brute force. For sure it's gonna take O of n cube, right? Can we do better? For sure. So generally when these kind of metrics questions are asked, um, your initial intuition should be to use a dynamic programming approach, right? Let's look at it, how we can solve it using dynamic programming. You take, and then you okay, so this is our matrix, right? Now what I'm gonna do is I'm gonna keep track of the state. So it's a very, if you visualize, it's a very simple game to track what is the maximum square we are forming as we go, right? So obviously uh, this row, the zero row and this zero column, um, uh, are gonna have the same values, right? Like, because like there is no, if this is a starting point, these have the areas as provided. Now when I start at this cell, because this cell is 0, I can actually avoid it. We don't care about it's being 1, right? um, then when I reach here, this one, so the base condition for me to have, like, there is a possibility that I might be a part of a square, right, when I'm at the cell which is 1, because we need to figure out the maximum area of a square having all the ones, right? So if I am here, I can form a square only if my neighboring cells, which is this side, this cell, this up cell and this cell, have 1 in it, right? Now it doesn't have one, so I just leave it like this, and I just store one here, right? Similarly, for this case, my neighboring is 0, so obviously I'm not forming a square till now, and this could be considered an individual square of 1. And similarly this. Now I come to the next part. This is 1 again. Now this is 1 again because the diagonal is 0. Now the catch here is when I come here, right? So what I do is I check that okay, my diagonal is 1, horizontal is 1, horizontal is 1 and vertical is 1, so that means I'm part of a square, and having this side, like this cell, would increase my side length, right? So I add +1 to it in case these neighboring ones are 1 or greater than 1. I'll see why I use the term. I'll explain why I said that we need to check that it has to be greater than or equal to 1. Like as we progress in this question. So next, when I reach at this one again, when I'm at this one, you will see that for this one I see a 2, but again I see a 1 and 1 for my diagonal and for vertical. So obviously I can't just simply take this 2 and add 1 to it, because then it's a rectangle being formed. I need to be consistent and with the sides, right? So I'm gonna take minimum of all the neighboring cells, which is I will take one is the minimum. So I add 1 to it, so it's 2. So this forms an area of 2 as well, right? This is the area that we are looking at, which is 2. Now next we go to this row, this becomes 0, this becomes 0. Now this again key stays at 1, right? And then this again stays at 0. Now let's see at an example where what if I had one here. So in that case my program is going to change. So it's gonna be 1 here, obviously, because this neighboring is 0, and so it stays at 1. Now for this one I check that okay, this is 2 here, diagonal is 1, diagonal is 1, so I take minimum of all the 3 neighbors and I add 1 to it, so this becomes 2. Now for this cell I see that the neighborings are all 2, that means including this, obviously it's adding one more side or one more length to already existing square, right? So I add 3, so I add 1 to it, to the neighboring, so this becomes 3. So because then this is the cell, right? So this overall code takes of n square time complexity. Let's see it in the code. I'm gonna use Java, so if I make mistake, let me I might be a little slow because I'm gonna make mistakes for sure in Java because it's a little rusty. I used it few years back. So int is equal to new int, and let's initialize the array to 0. So for 0 n, So in the example we saw, we only care about the minimum of the neighboring cells, and we check if it's 1, we enter it at 1, otherwise it's 0. So I'm gonna check whether matrix of I comma j equals 1, then only enter this loop, else we assign to 0, and then here I check if I minus 1 and j minus 1 is greater than is 0, minus 0. So then I check, I simply take, if it's not, then I take because if it's a 1, so I take dp of I comma j equals to 1, else I take the neighboring ones, could be dp of I comma j could be equal to mat, so it will be 1 plus, right, because I'm adding it to it, mat dot min of dp of I minus 1 j minus 1 comma mat, because as we saw, if it's equal to 1 and if this side neighboring sides exist, so I just take a min. So if the min is 0, then it will be 1 here itself, right, because I'm adding plus 1 to it, right. Otherwise if it's 1 1, then it will become 2 as we saw here, and if it's 2 2 2, it becomes 3, right. Cool. And then we iterate again for the max area. So once we have the values of the sides, the max side, we just square them. So max area is, I just iterate over it again. Or actually I can just take I can calculate it after this, inside all the else's here. So max area right, yeah, and then we return. Let's run it and see. We should be getting 4 here. Awesome. Let's submit it. Java out of box. Okay, we need to check the emptiness if 0, obviously it's never gonna be less than 0, but this is like a more secured check that I like to put. So let's submit it. Awesome. I hope you guys enjoyed this video. It was pretty interesting problem, and we got to solve dynamic programming question. It's one of the toughest topics to prepare. If you like this video, please subscribe to my channel and give me a thumbs up. Thanks everyone.